Okay, so the first part was just asking you to list the zeros of the function. We talked about yesterday how that's the x-intercepts because that's where y is 0. So for this first graph, it would just be at 1 and -3. So that's all we had to write here. Then looking at the second graph, you can see that it crosses the x-axis at -2 and positive 1, 2, 3, 4, 5. So that's what we write right here. And then looking at the third graph, which is called h of x, we have two x-intercepts as well, one at -1, and then one at -2, -3, one at -4. So -1 and -4. So there's all of our zeros. Here's the two zeros for f of x, the two zeros for g of x, and the two zeros for h of x. Okay. Here, it asks you what the zero product property is. So you can explain that. It basically is just that when you have two or more factors that have a product of 0, that one or more of them have to equal 0 or can equal 0 to make it true. So for this example, it was asking you basically saying, okay, here's an example of the zero product property. So solve this. When you have this, then you do what? So in this section, you should have showed me how to solve this equation using the zero product property. So it should look something like this. You set each factor equal to 0. You solve both equations, and you get your two possible values for x. Now for this part, it says in the example above that the x plus 1 and the x minus 3 are called linear factors. Okay, well, first of all, we already knew they were called factors because we've been calling them factors the whole time. They're factors because they're two things that multiply to get something else. Okay, because x plus 1 times x minus 3 equals 0. That makes them factors already. Now, what makes them linear is what we discussed a little late yesterday, was that they are first degree polynomials. This is a first degree binomial. So if I was to graph like y equals x plus 1, it would be linear. It would be a straight line. The same thing with x minus 3. If you graph a first degree polynomial, it's a line. And that's because those are linear functions. So these are linear factors because they're factors that are first degree polynomials. Okay, now this asked you to use a graphing calculator, which you can just use Desmos.com. That's DESMOS.com if you didn't figure that out yet. And just to type this in. Okay, it should work if you type it in this way too, but also if you wanted to just make that a y instead of a k of x, it would graph that just fine for you like that as well. Okay, so let's see what it kind of looked like when you graphed it. Now, when you did graph it, it should have looked basically like this. You can see we're looking for the zeros of the function. Well, the zeros, it crosses at -1 and +3. So I listed my zeros here, -1 and 3. Now at the top of the next page, it's asking you to look at these two numbers, the two zeros, in comparison to what you got when you solved, or the linear factors. Okay, if you noticed, this was the same equation that you graphed and the same equation that we solved. Well, when we solved it, we got x was -1 and 3. And when we graphed it, the zeros of the function were -1 and 3. Now it's pointing this out because now the question is if you have the zeros, could you work your way backwards to the linear factors so that you could have the equation? Okay, so now what we have here is a definition that's basically telling us that the equations we were looking at are called factored form. Okay, they're factored form of a quadratic function. Okay, so all of this is really just saying that these P and Q just come from the zeros of the function. And as it points out, our A value so far is 1. That's why we don't have a number in front. That's the next page that's going to talk about the A value. So for now, we're going to just leave A1 so we don't have to write it. And we're going to just try to write the linear factors of those three quadratic functions that we had from the front of the page. Okay, so first, just a reminder, on the front of the page, you can flip your page over and look, but the zeros were 1 and -3. So if the zeros are 1 and -3, then how am I going to write the two linear factors for this function? Okay, I'm going to write them as x -1 and x plus 3. Now, there's two ways I can look at that. I can look up here at my formula that they gave me, and it says x minus a 0 and x minus the other 0. So if I do x minus this first 0, that's x minus 1, and then x minus the other 0 is x minus -3, which would be x plus 3. That's not the way I like to look at it. I like to look at it as these are the things I got when I solved this. So all I need is a polynomial that when I solved equal to 0 would give me this number. So what's going to give me x equals 1? Well, x minus 1 would make x have to be 1. And then what's going to make x -3? Well, x plus 3 makes x have to be -3 to equal 0. So that's the way I like to think of it, is what would make the x have to be this number in order for the polynomial to be 0. All right, so we have the zeros for g of x are -2 and +5, and the zeros for h of x are -1 and -4. So the linear factors here are going to follow the same pattern that we did to get the first one. Okay, I'm going to have x plus 2, because that would give me a solution of -2. And I'm going to have x minus 5, because that would give me a solution of +5. And for h of x, I'm going to have x plus 1, because that would give me a solution. When I set it equal to 0, it would give me a solution of -1. And x plus 4 equals 0 would give me a solution of -4. Okay, so this is how I work my way backwards from the zeros to the linear factors. And this is just asking you to graph it and confirm it, although the only thing that you're confirming really is the zeros. So when if you graph these, just make sure they have the same x-intercepts as the ones on the front. And then it asks you to explain in your own words how to do this process. I can't talk you through that because that would be my own words, not your own words. Okay, so take everything we've done and make sure you put it in your words to explain how you go from the zeros to the linear factors.